is related to the next examination, which is operating systems. This is for module 3, numericals. The theory part for this is already uploaded, so please go check it out. This is one of the easiest modules for numericals. So let's get started. We will be given allocation, max, and available. First, we need to calculate the need matrix. So how to calculate the need matrix? It's very easy. This question is taken from the supplementary examination, June-July 2024. Okay, so the formula for need matrix is maximum minus allocation. So the maximum is given here and the allocation is given here. So let's just subtract them both and calculate the need matrix first. 7 minus, okay, so first we check 7 and then 0. 7 minus 0 is 7. And then 5 and 1. 5 minus 1 is 4. 3 minus 0 is 3. And we have to calculate for each of the processes. So we've done it for P0. This one is P0 and we have done it for P0. Now let's go. 3 minus 2. So this 3 minus 2 is 1. 2 minus 0 is 2. 2 minus 0 is 2 again. 9 minus 3 is 6. 0 minus 0 is 0. 2 minus 2 is 0. 2 minus 2 is 0. 2 minus 1 is 1. 2 minus 1 is 1. 4 minus 0 is 4. 3 minus 0 is 3. 3 minus 2 is 1. So this is how you calculate the need matrix. This is very easy. And then we also have to calculate the safe sequence. So the meaning of safe sequence is nothing but the sequence in which the processes gets executed without entering into a deadlocked state. I'm assuming everyone knows what a deadlocked state is. So we have to check for each of the processes the need matrix for each of the processes. So how we do is, this is just think of it as common sense. We need these many resources, and these many resources are available. So um, let's start with P0. So we need 7 resources of A, and we only have 3 resources available. If we start executing this, we need 7 and we have 3. So the system is definitely going to enter a deadlock state, and we do not want that to happen. So we have to select the need matrix of the process which has less needs than the available. For example, the next one. So see the next one, 1, 2, 2. We need 1 of A, we have 3. We need 2 of B, we have 3. We need 2 of C, we have 3. If we have more, it is not a problem. If we have more available, it is not a problem. But if we have less than what we need, then it will enter a deadlock state. So we have to check for that. So P1 can satisfy the available P1 process can satisfy. So safe sequence P1 will go into the safe sequence. After we figure out which process can execute without entering into a deadlocked state, we need to write that in the safe sequence. And after writing it in the safe sequence, we have to add the allocation matrix of the corresponding process to the available. Now we have P1. This is the allocation matrix of P1. We need to add this to available. So now 3 plus 2 is 5. 3 plus 0 is 3. And 2 plus 0 is 2. So this is the new so this much is available now. Then we have to check the new available uh, and compare it to the need matrix. Now we go to the next. The safe sequence can be any sequence, it does not matter. What we have to check is the available, the end, what we get in the end, the available, it has to be correct. And I'll tell you how to confirm that if it is correct or not. Next, let's check with P2. We need 6, we have 5. We need 6, we have 5. It will not be satisfied. So next, let's go to P3. We have 0. We need 0. We have 5. We need 1. We have 3. We need 1. We have 2. This will satisfy. So now let us write P3 and then add this allocation of P3. So now 5 plus 2 is 7. 3 plus 1 is 4, 2 plus 1 is 3. This is the new available. Now let us compare this one. So we need 4, we have 7, we need 3, we have 4, we need 1, we have 3. This will satisfy. We will write P4. Now we will add this. 7 plus 0 is 7, 4 plus 0 is 4, 3 plus 2 is 5. Okay. Now we will compare. Now these three are done. We have P0 and P2 left. Now we compare P0. We need 7, we have 7. We need 4, we have 4. We need 3, we have 5. This will satisfy. So let us write P0 and add this. 7 plus 0 is 7. 4 plus 1 is 5. 5 plus 0 is 5. Now let us check the P2. This is also satisfied. We need 6, we have 7. We need 0, we have 5. We need 0, we have 5. So let us add this to the same sequence and then add it. This one. 7 plus 3 is 10. 5 plus 0 is 5. 5 plus 2 is 7. So this is the answer. This is the answer actually. Now, in order to verify if this is correct or not, we have to add all this. 3, 4, 5, 6, 7. 1 plus 1 is 2. And 2 plus 2 plus 1 is 5. Now we take this. Let me write it in another color. Now we add this. This is 7. And this is 1 plus 1, 2. And this is 2, 3, 4, 5. So this is 5. We take this and we add it to this. So 7 plus 3 is 10. 2 plus 3 is 5. And 5 plus 2 is 7. This answer and this answer must be the same. This is nothing but total resources. Okay. So this is how you find the CF sequence as well as the need matrix. And this will fetch you around 7 or 8 marks, I believe. And this is very easy, so please be sure to attend it and not skip it.